This is a solar motion model. How it works is this green disk represents where you're standing on the Earth. And these lines all the way around the outside, they represent the hours in a day. So in any given day, you can count based on the motion of where the sun is, how many hours you're going to have daylight and how many hours you're going to have darkness. There's a notch right up here by north, and if you insert it into this blue circle, you can choose your latitude of where you are on the Earth, between 90 degrees at the poles, 0 degrees at the equator, or somewhere in between. So I am going to choose 40 degrees north for where I live in Utah. This brad over here on the right is a slider, and you can change it between the summer solstice or any month of the year. Here it is at the spring and fall equinox, and all the way down here is the winter solstice. So you can see in Utah, if I move this back and forth, you're going to have many hours of darkness, a few hours of daylight, and a lot more hours of darkness in a 24-hour period. If we counted those up, you could look at these black notches on this surface of the Earth and count how many hours are actually daylight. So making sure this stays at 40 degrees, you're going to move this model and it crosses the horizon somewhere around this mark, 2 down from east. And it is daylight above, and then it will cross again 1, 2, or 3 notches this way. Sorry, did that stay right there? Yeah. So you can count 1, 2, 3, 4, 5, 6, 7, about 8 hours of daylight on December 21st, and 24 minus 8 would be the hours of darkness, so about 16 hours of darkness on the winter solstice. If I move it up here to March and September, you will see that the sun rises directly in the east and sets directly in the west, which means equal hours of daylight, equal hours of night. And if you count the notches, you will get 12 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now moving it up to the summer solstice, you can see the sun, let's make sure we're back on Utah, angle is high in the sky. Down here, winter, it was low in the sky, so we're having direct rays of sunlight hitting us on the Earth. 1, 2, it's about 3 notches north of east where the sun will rise, and about 3 where the sun will set. So in all, that would be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, almost 18 hours, maybe 17. And we would subtract that to get the hours of darkness, or the time when the sun is below the horizon, down here. Okay, so let's do the equator. 0 degrees latitude. During, what is this? Sorry, it's hard to read. During summer solstice, the sun will rise and set in the north. During March and September, it will rise and set directly east and west. And during the winter solstice, it will rise and set in the south. Contrast that with the poles. Here at the North Pole, winter solstice, the sun will never rise above the horizon. And this is where you'll see the 24 hours of darkness that we get during 3 months of the year. Actually 6 if you're directly at the North Pole. Move it to summer solstice, the sun will never set, and you'll have 24 hours of daylight at the North Pole. If you move it to spring and fall, you'll see that the sun will just hover right around the horizon. It doesn't rise, it doesn't set. So it'll be twilight for the spring and the fall equinox. You might see a little bit of light, so you might say 24 hours of daylight. You might say 24 hours of darkness because the sun really doesn't ever come up, but it just hovers there right on the horizon.